Hi, I'm Dave here. So today I have this beautiful 7812, which is a dual trace amplifier plugin for the 7000 series oscilloscope mainframe from Tektronix, obviously. It's really in quite nice condition, which is kind of rare to find here, especially here in Europe. But anyways, this is a 105 megahertz, bandwidth dual trace amplifier. It's a beautiful, very interesting plugin because it doesn't have the usual, selector like knob like this time base, but they usually have a little knob that you can turn. This one has little selectors here, those little push buttons that set the volts per division, so the attenuation basically. Which is very interesting. Those are kind of a programmable plugins, sort of. But anyways, there's a known fault on those kind of push button programmable plugins, is that they are relying on relays to switch the attenuation inside. So those relays are known to, they tend to go bad after, all those years. Actually dates from the 70s. So yeah, all those years. It kind of still works. I already tried this thing on my 7603 oscilloscope. Still works, but it needs some love and care. So, and I'm gonna open it up, see if everything is good, and I'm gonna clean the switches, kind of restore it, and then I'm gonna go and perform a very quick check and calibration of this plugin so I can actually use it on the oscilloscope. So let's turn it aside and open it up. So obviously those plugins are very easy to disassemble. Just remove the panels, no screwdriver required, and we are in. Look at that. That is beautiful. Everything inside is gold plated. The actual channel 1 input. You can actually see those are practically identical. Look at those. Very nice. Those are all the switches on the front. You can actually see the mechanism, and those are the little light bulbs to illuminate the front switches. And I can now enjoy the illumination because I made a little modification to the 7603 to actually provide the plus 5 volts for those little light bulbs. I'm gonna link I'm gonna provide a card here so you can go and watch that video. Alright. So obviously all the magic happens behind these covers. Alright, so this is the inside, and this is the actual attenuator section. You can actually see those very rare relays to find nowadays, obviously. And there are ways of, replacing those. Those are actually socketed, so you could actually replace those with modern equivalents. Or you can kind of rejuvenate those, because basically the contacts become bad because there is oxidation and everything on those poor little relays that have so many years on them. So there's a little bit of oxidation between the contacts, and basically you don't have a perfect contact anymore, but a resistor, and so it's not good for this section of the instrument. So you have all those kind of problems. Yeah, you can actually see all the sections here. So basically you have the input right there on the far left side. Is the actual AC coupling capacitor that is switched. So the AC or DC coupling is switched by this relay here. And then those relays have the attenuation. So you see resistors and capacitors here. This is the high frequency compensations of all the attenuator, because basically you have a pure resistive attenuation for low frequencies, and since this is a 100 and whatever, but it's more than 100 megahertz plugin, you basically then becomes a capacitive divider. So yeah, you have resistors and capacitors here. This is all those can be set, but I'm not gonna touch those at all because I don't have the equipment really to perform this kind of extensive calibration. Alright, so after all the input attenuations here, the signal passed through this section here, which is the input amplifier and offset generator. Everything is basically done by this little package here. This is the input amplifier and also takes part in the offset generator. This actually drives this IC that you see here, which is a custom IC obviously from Tektronix, and it's a paraphase differential amplifier. And it's so important that paraphase differential amplifier, the U225, that they included a block diagram of the whole thing in the manual. So there it is. This is the actual differential amplifier that drives the whole thing. Speaking of amplifier, this is the actual amplifier board for this channel. Obviously I'm showing one channel because the other one is perfectly identical to this one. So we have the custom IC here, which is the paraphase differential amplifier, and this other IC, which is very important because in this section here all the logic, all the switching logic happens, and this U300 IC is both the signal switching IC and also the trigger switching IC. Obviously it's a custom IC as well, and yeah, Tektronix loves to make their own custom ICs. On the other side, obviously all those boards are perfectly identical, with the exception of the base board, the main board, which is the actual interface board. And yeah, there's nothing really special here, but those are not custom ICs, which is, yeah, it's nice. And by the way, the actual interface board is a multi-layer board. Look at that. There's the traces on the top. There's a ground plane that is on the middle here, just behind the top traces. And if you look on the back, you can actually see there's the bottom traces and a trace in the middle. So it's at least 4 layers. That is fancy, from the 70s. So here is a close-up shot of this beautiful, clever design here for the little input attenuation switches. You can actually see this little light bulb here and this light pipe construction. This is done to illuminate more than one, to don't have, just a single light bulb for every switch, but you just have one for 1, 2, 3, 4, 5 switches. So you can see this light pipe here, so light goes here, gets reflected here, and you can actually see behind here, every switch, there is a little cover, covers up the switch, obviously, and when you press it, this cover actually lifts up. So basically when you press a switch, the switch, obviously the button is clear, it's transparent, so the light goes here, gets reflected here, goes through the light pipe and through the button, and you can actually see the light on the front. How clever is that? Alright, so I was actually checking the functionality of this thing, and everything is actually working very nicely. But I have a small contact problem, which is classic on those Tektronix plugins which use relays. And the relay, which is not really working very nicely, is the coupling relay. So the relay that basically switches between AC ground and DC coupling. So you can actually see I have the probe attached to channel 1, and to the calibrator should be a perfectly good 4 volts peak to peak square wave. And no, it came good. Oh geez, that's Murphy again. Every time you want a thing to not work. Before I switched on the camera, obviously this was all distorted, and if I can reproduce the thing, but now it came good. Oh no, there we go. There we go. That's what I'm talking about. Look at that. That should be ground. That is not ground, and you can actually see it's intermittent, and it's not the probe. The probe is perfectly good. It's the actual relay. See if I can actually make it good like that, but no. You just need to switch the thing a couple of times. You can actually see that. Now it came good again. Alright, so now it's nice and warm, and it's nicely exposed this way, so you can actually see all the test points are almost all in the side here, so it's very, very nicely made. So I'm obviously referring to the manual. So the basic check, the first check to do is obviously the voltages. So we have plus and minus 15 volts coming in here, plus and minus 50, and there's a regulator which is composed by those two operational amplifiers and a Zener diode somewhere here, this one, and this provides the plus and minus 9 volts that drive all the amplifier in this thing. So that has to be very, very stable and spot on. So we have the plus and minus 9 volts, and it should be within 50 millivolts. So yeah, I'm gonna check it. Well, let me get the clips. There they are. So ground, there are a bunch of ground test points. So there we go. This is ground, and so the plus 9 volts also sets the reference for the minus 9 volts, and I'm gonna adjust it to be exactly 9 volts. Very good. Now I'm gonna, I don't trust this thing. I'm gonna test it with my Keithley multimeter, which is, has more resolution and is also more accurate. That's close enough for me. I'm gonna just go and measure the minus 9 volts. I'm gonna adjust it. All right. 899136 was really out, this one. Well, that's close enough. Alright, so next thing is to check the 3.5 volts. And there we go, that's should be plus 3.5 within 350 millivolts, and that is pretty good. It's 3.428, so that's perfectly within range. Alright, so next thing is to check the channel 1 DC balance. And we should see if we switch the polarity to inverted, we should see no more than 0.5 division trace shift. Wow! Oh, it needs a little bit of calibration, just a tiny little bit. This guy here, so if I move it, should bring this down, and I should switch between. Alright, so let's put it there. So switch between the two and adjust it so I can bring it really close. That is way better. That's close enough. Let's go and see now if we go on up here, and I'm gonna switch from 5 millivolts to switch between 5 millivolts and 10 millivolts, so we can see DC balance here. Alright, that's very good. That's not moving at all. Alright, so look at that. I adjusted a little bit more. There's no movement. So let's see the channel 2. So let's see the DC balance. Let's bring it to the center. And then let's switch to inverted. Wow! That is so much. Alright, let's get it right. Let's see. Oh my god. That is way out. That's a little bit better, isn't it? Alright, so channel 2 is done as well. Look at that. Beautiful. Channel 1. Oh man. Channel 1. Let's switch. That's perfect. Channel 2. Very good. See, 5 millivolts. Doesn't even move. Yeah. Perfect. Right, so the next thing would actually be to check the gain. Check and adjust the gain of the two channels. So I'm gonna go and insert a 4 volts peak to peak signal, which is exactly 4 volts. It's calibrated, and I'm gonna switch to DC, and it's 1 volts per division, and it's way out. All right. So where is this? Oh man, that's almost half a division out. So let me adjust it, just the gain a little bit, and that is pretty close. Yep. Put it on DC. 1 volts per division, and it's way out. Also channel 2. So let's adjust the gain. So right there. A little bit there. I think let's put it on the center. That's should be 0. Should be 4 volts. 1, 2, 3, 4. Perfect. Alright, so this is such a great instrument. I just want to keep it for myself. And yes, by the way, you can do XY mode with this specific time base, which is the 7B53A. And you just put it on the amp mode, and instead of the trigger, you have the second channel right there. But anyways, I didn't do the frequency compensation adjustments because I don't have a pulse generator that is good enough for perform some the frequency adjustment calibration. So I'm not gonna do it right now. Perhaps in the future I'm gonna actually adjust it if I get a proper instrument. So this is gonna look at the persistency of this scope. It's just amazing. But anyways, I hope you enjoyed this little quick tour about of the 7A12 dual trace amplifier. And just a very quick and dirty calibration. Was a little bit out on DC balance and gain. So with that adjustment done, it's gonna be good for most applications. Alright, so hope you enjoyed, and as always, thanks for watching, and I'll see you next time. Bye! That never gets old. Wow, look at the persistence. That is quite something.